Hi everyone. Thank you for all your well wishes in the previous post. I got hit quite hard with the flu this time. I'm one of these people that's very driven and I don't sleep a whole lot, and I've been warned about this, but you know how that goes, right? So finally my body said, okay, that's it. You're going to take downtime, and it sure took revenge. So it's been about 18 to 20 years since I've had anything like this, and this really knocked me on my backside hard. So this was a pretty bad flu. You're probably, still hear it in my voice, and I'm going to do my best not to make any sniffling noises or coughing in this video. So I am on the mend. I'm definitely on the upswing now. So I appreciate all of your very kind responses to that post. So since the last video with that small circuit board, I've had many questions, many PMs and emails about showing my technique to soldering these very small components onto surface mount boards. And that's what I'm going to show you in this video, because we do a little bit of everything in these videos. We'll be, soldering circuit boards, and, we'll be doing point-to-point work, surface mount, through hole, all sorts of lots of different types of soldering. And since a lot of these boards that I've been doing lately deal with surface mount components, I'm going to show you my technique, and it really does make it quite simple. And I'm not talking about having to use hot air to do soldering or anything. I'm just talking about a plain old soldering iron and some tips. And I'm going to show you the tips and the part numbers of all the stuff that I use here. They're very important stuff at any rate, so that you can get set up. And I'll give you some suggestions as well to make your soldering that much easier. So this is my technique, the technique that I use to solder my boards, and I find that it works quite well. So I'll get all of this stuff here out of the way, and I'll start explaining a little bit about each one of these things that I do have here on the bench. My two favorite soldering iron tips for my irons are these two right here, and I'll give you the part numbers here in just a moment. So this tip here is a really good general purpose tip. This works good for a lot of through-hole work. You can even do some larger surface mount work with this, and this works really good for point-to-point work. Just a general kind of, I wouldn't say in the middle, but it works really good for just about everything kind of tip. Now, the part number of that tip is T18-D24. And of course, this is for a Hakko or Hakko product, however you want to say that. Now, one of the reasons that I choose this particular brand right here is because the 936 is kind of where it all started, and so many different companies have taken that iron and they've pretty much used the same platform. So these tips fit so many different types of irons. I have a soldering rework station that has, it's basically just an offshore iron, and it takes the 936 tip, and that's really what these things are. These tips fit the Hakko 888 or the FX 888D, and that's the irons that I have. I'll just move this out of the way, and hopefully there's enough cord I can pull this through and show this on camera. It's getting pretty tight. There we go. So this is the 888D right here. It's on. That's where I have this set to in degrees C. So this is the one that I normally use on the main workbench right here. And I have another one exactly like this for surface mount use, and I use the other tip for that. So this is a good all-around temperature for just everyday soldering. Let's put that back in there. And I have one of those tips on here right now. So that tip is on here. This one right here. So again, really good all-around everyday tip. You'll find you can get away doing most work with this. But when it comes down to doing surface mount work, this is the tip that I prefer right here. It has a little twist in it here right at the end, and you can use this so many different angles, and you can really get a lot of heat on a component if you apply it like this, or you can get a real fine tip right in there if you need to solder a really small area. It's just, again, an all-around great tip. These are my two favorite ones, and I have a lot of tips that I choose from. So I have a whole bag full of these types of tips. Again, same kind of thing. This is, pretty much started with a Hakko 936, or Hakko 936. And these fit so many offshore irons. So I prefer to use the genuine. There's a lot of, I call them Fakko, because there's a lot of fake tips out there, but there's a lot of Fakko tips out there. And they work well, but these ones here, they seem to last just all that much longer. The genuine tips, they really go for a long time. Another thing in tip life that's very important to remember is always keep a little bit of solder on the tip. So there is always waste product. That's just the way it goes with soldering, and it's the way it goes with a lot of things in industry. You can't wipe the tip off on the sponge and put it back in the holder and leave it there. If you do, the tip will be destroyed in very short order. There always has to be when this goes back into the stand, so when this thing here goes back into the stand, there always has to be, you can see I haven't cleaned this, there always has to be a really ugly ball of solder just hanging on it. And then you put it back in the stand, and then before you use it, you can either use something that looks like this. I like to use this for surface mount work as well, or you can use a wet sponge. Now with this, there's a lot less thermal shock to the tip, and you'll find that the plating won't come off. All of these tips have a plating on them that's very fragile. Get this into focus here. So what I'll do is I'll grab some solder, some bigger type solder. Got all the stuff for surface mount here. So, all you do is you basically just poke this in here, give it a couple of twists, and poke it in a few times, and it cleans it up really nicely, and it gets all the debris off. But once you've done that, again, immediately you need to put some solder on that tip before you put it back in the stand, or that tip will go away. And that's just the way it is. And that needs to be remembered whenever you're doing any type of soldering. Never put away a dry tip. Never sand these tips. So many people seem to think that, when you're done with a soldering iron, you sand the tip. It's some sort of old wives' tale. I guess it was, taken back from eons ago. Even if you have a copper tip, you can heat the tip up and wipe it off. And the copper is usually just fine. You don't need to file a tip. Now, with the old copper tips, copper erodes with solder. So if you were to use a copper tip for any length of time, you'd most likely have to file it back into shape. But over and over and over again, I keep seeing people that, want to take a file to these newer tips. And it's like, don't do that. What are you doing? So if you file the plating off these tips, they'll go bad within a day of just sitting in the stand with solder on them. Solder will actually cause this to erode and go, you get flat spots and the tip will go missing and things like that. So if you had a solid copper tip, filing might be necessary, especially when the solder erodes the copper. But with any of these new types of tips, you never file them. Now, the wet sponge thing is another thing for debate. All of these soldering iron stands, you can see mine. So this is mostly from flicking solder into an area. Just flick it down here like that. But what happens with this is when you wipe the tip on the sponge like that, so I'll just have some solder ready here, and I'll do that. I never like to leave this. This really cleans the tip off well. Okay, so when you do this, all right, it cleans it off really well. You can see how incredibly clean that is. So I immediately have to add solder to that. If I don't, something will go bad really quick. So a long ways away from that, as you can see. So I definitely want to keep solder on that, but it cleans the tip off very well. But there's another thing that shortens the tip life, and that's the thermal shock of this cold water. So you'll find that when you have a really, really hot soldering iron tip, say 370 degrees C worth of soldering iron tip, and you dip it into water like this, the thermal shock is really quite intense on the tip, and you'll find that it'll greatly reduce the tip life. Whereas one of these things, you don't get that. So, and even if you're, dipping your soldering iron into a puddle of solder on a circuit board, it takes a while to heat that puddle up to get to the temperature of this. So it really doesn't pull the outer temperature of the tip down so fast as dipping it in water. So these things here really do greatly extend tip life. So now I use a combination of both. It's kind of, in a worst case scenario, I'll use the water to get all the crud off the tip, because a lot of times it will bake on. So, to get all of this kind of crud off here. Or, if it is, say it's not too incredibly stuck on, or it's, the tip isn't looking too incredibly bad, you just poke it in here and give it a few twists and pull it out, and usually that does well. And this thing here is kind of crucial for surface mount soldering as well, especially when you start going down to 0402. You have to be very careful with the solder that you leave on the tip when you actually do the soldering, and I'll get into that here when I actually do some 0402 soldering here quite shortly. So these things are all really handy to have. These you can find at any electronics parts store. These things, they look like a kitchen scouring pad. In fact, I have some stainless stuff that's like this that looks identical to this, but just stainless. So these things here are really handy to have. Get a couple of them for the bench. They're cheap. So the second tip here that I use, which is the part number here, it actually has a DigiKey part number still on it, is 1691. So get that into the shot there. 1691-1167-ND. And the actual tip number is T18-BR02. And this one here is my absolute favorite for surface mount work. So this tip is for me definitely the best for that type of work. And I go right down to the smallest stuff you can imagine using this tip. So, 201 right down there, 402 right down to the smallest. So 402 is the stuff that you saw in the last one. That was the smallest components that I use. And that's the smallest component that I'm going to use in any of my projects here. So I will go down to 0402. 0402 is getting pretty small, and I really don't want to be going any smaller than that because there really is no need. The space saving after that is, we're starting to get into working with BGAs and things like that. So, and that's another thing that I'm going to try and do is try and keep away from using anything with any kind of a hidden solder connection so that you can do most of your soldering with an iron so you don't need to reflow anything, or heat anything up to make it stick. So I'll try to use exposed leads on all of the projects just to make it that much easier. One day down the road, if I do go into, doing BGA work or something like that, I'll just have a dedicated video or videos to that particular thing. But for building projects, there really is no reason to go that small. So 0402 is still a realistic size. You can see it, put one in your hand and you can actually still see it. And if you have a magnifier, there is no problems with 0402 whatsoever. And I'll talk about magnifiers here in a little bit as well. You can use so many different types. You don't need a microscope or anything like that. So these are the two favorite tips. And if you're thinking of getting another iron, get something that is compatible with these tips because there are so many on the market. And there is no reason to have any crazy fancy soldering iron. Anything that fits that, like, as I say, like the FX888D or the 936 or even one of the clones is absolutely fine. These tips, there's so many and they're so cheap and they work so well. There's no reason to go with any of those crazy soldering iron tips. I never have had to myself. It's pretty much all in the technique. So the magic's in you, not in the tool. Tools definitely help, but it's all really in the technique. And I'll get into that here quite shortly as well. Solder diameter is also a really important thing when you're working on surface mount stuff because you really don't want to flood the area with a huge chunk of solder. It's almost like you have to nip a little piece of a larger, if you had a larger diameter solder, you'd have to nip a little piece of it off to use it. So when you're doing some very fine work with surface mount stuff, choosing the right diameter and, of the actual solder is a really, really helpful thing. This is some very small stuff here. The diameter is 0.015. So I have all sorts of different types, and I also have lead-free as well. So if I'm working on something that's usually on a piece of ceramic, so a ceramic substrate or something like that. Usually what happens on ceramic substrates is they have, the actual traces they use are basically a high silver content. And if you don't use a solder that has a little bit of silver in it, what ends up happening is the trace will migrate from the actual substrate to your soldering iron tip, so it'll just disappear. So say I was to just touch it with a piece of 6040, that's what this stuff is. This is my favorite stuff right here. So 6040, so if I was just to touch a little bit of 6040 onto one of those traces, there's a really good chance that when I remove the soldering iron tip, there'll be a little spot there and it'll actually have taken the trace off. So if you're going to ever work on anything that has, that is on a ceramic substrate, you'll find that in a lot of modules in, say oscilloscopes and things like that. What you want to do is you want to clean all of the solder off of the tip of your iron. So you wipe it down on a sponge really, really well. This is one of those times and you really can't get away from that thermal shock. So wipe it down really well, coat it, coat the tip of your iron with solder, make sure that it's all over it, and then clean the thing off again on the sponge and then do it again just to make sure the only solder on the tip of your iron is it has tin, silver, and copper in it. And at that point, then you're okay to work on something that has a ceramic substrate with those silver traces on them. That way you won't get migration, or there's a lot less of a chance to get migration. A lot of the times you'll also find that you'll have to turn the heat of your iron up very, very high because the ceramic will sink the heat off of the trace that you're trying to touch or the component that you're going to try and solder onto that little pad. the ceramic will just wick the heat right off of it. So sometimes you have to use some very high heat. Another very important reason to use the correct solder for that kind of stuff. So that's basically the only time I use this stuff right here, is for that. I prefer 6337, or I prefer this, 6040 stuff. Now, this is my favorite type. I have this in all sorts of different diameters. Let's see if I have the other diameter sitting around here somewhere. I have so many rolls of this stuff. Here it is. It's a larger diameter for doing point-to-point stuff. So this stuff is really good solder. You can find this stuff around. And it's YIKST, Solder Manufacturing. This stuff here is what makes those really nice looking soldering connections on all of my small circuit boards. This gives a really nice, almost like a chrome appearance to every little solder connection. And this is really easy on soldering iron tips and things like that. Now, of course, this is a leaded type solder, so you need to use what's good for you. I don't mind using that type of solder at all for any of my own projects, but if you find that you're more comfortable using lead-free solder, you can use that as well. So again, this is a lead-free type of solder right here. Works very, very well. Lead-free solders, they, I guess you could say, when you're working with a lead-free solder, it acts a little bit different when you're trying to, do soldering with it like that. So I'll get into that, the differences between leaded solder and lead-free solder, in a different video that's really going outside the scope of this right here. But my two favorite types of solder, again, 6337 and 6040. 6040 being my absolute favorite, and this brand is my favorite. Now, I'm not sponsored by these people at all. This is just a solder that I found that works very well and leaves very, very nice solder. After you're done with the job, it leaves a very nice finished product. So one of those people that take pride in the way the solder looks on the circuit board and in point-to-point and things like that. Another thing you might want to do, keep in mind, is make sure that your soldering iron is actually what it says it is. A lot of the offshore soldering irons are way out. I haven't calibrated mine for a while. Actually a very long time. So it's 370, like you saw there. So this here is the little sensor down on the bottom, and they're replaceable. You can see when I do this, it loosens it off. They're replaceable, and these usually come in a pack. So what I'll do is I'll just back the focus out just a little bit here, or the zoom out just a bit. And I'll add a little bit of solder to the tip here, and I'll put it on here. Let's see how close this is. And it's actually cooled off quite a bit. Give it a little bit more. Make sure you get good thermal connection. That's one of the big things. So pretty close. 361. Not bad for not calibrating this thing forever. 362. Maybe if I even get a little bit better thermal conductivity here. So 363, so very close. It's close enough to 370 that I'm not worried about it at all. So there it is. These things are handy to have. You can find these things around, the FG-100. And these usually come with a whole kit full of these little sensors on the bottom here that you can replace if you get them crudted up. This is still my original one, and I've used this for a long time, so I imagine I'll never run out. And handy little tool to have around just to check the validity of your iron. I'm going to tell you this, if you have an offshore iron, and I have a few of them, the temperatures are all over the map. It could say 370, but it'd be like 290. That's how far out some of them are. It's incredible how far out. Hakko products, or Hakko products, they're usually spot on. So I've really taken a liking to this company, and I like Weller products as well. But for irons and stuff like that, I'm really, really sold on these things. I changed years ago. I had Weller irons and Weller this and Weller that. They're a good product, but just the versatility and just the way that these things work, they really stuck with me. And again, no, I'm not sponsored by this company at all in any way, shape, or form. They just really make a good product. I have the 936. I have never replaced an element in my 936. That thing has to be 25 years old, something like that, maybe something crazy like that. It's incredibly, it's just a very, very dependable iron. And it's the same with these FX888s. I've had them for quite a long time and no problems at all. So I'm just really happy with the products. So there is that. Now, when you're doing surface mount work, another thing to keep in mind is a really good pair of anti-magnetics, so something that's not magnetic, pair of tweezers. And as you can see, again, these have the curve at the end, and that is really important to have. The ones that come straight on, you'll find yourself getting aggravated with. So you want a pair of tweezers that do have a curve, and ones that are definitely not magnetic. You can see stainless, anti-magnetic, anti-acid. Very important for work. Now, when I'm holding the component, I hold the component usually in this hand, and I'll solder with this, or I'll go back and forth like this and like this. It just depends on how you're comfortable. With the soldering iron, I've learned to pretty much use either hand and be versatile with either hand. And just because you find yourself working in so many different positions. But if you're comfortable, say working like this, that's absolutely fine. You can work like this, hold the component here, tack the component, and, of course, move the thing around and tack the other side. And I'll get into that here quite shortly. So whatever way you're comfortable with, I can, either way, right? It doesn't really matter. So whatever makes you comfortable, and however you're comfortable soldering, there's lots of ways of holding an iron tip. The real trick in the surface mount soldering is in the holding of the component in this here, and I'll show you that really shortly. So what else do I have to show you here? I think that's it. Oh, one of the most important things, can't forget this, is flux. This stuff is what makes everything work. I had a really interesting comment on just regular YouTube channel a few weeks back about some fella. He says that, you don't need flux. It's just a waste of time. You should be able to solder without it. It's one of the most ridiculous things I've ever heard. That's like trying to take a welding rod and chipping all the flux off it and trying to weld with it. It just doesn't work. So what this does is this boils the impurities off the board, basically brings them to the surface and allows your solder to stick. And flux really is the magic, and you need to use this stuff whenever you're working with your own surface mount circuit boards. So I do have RA Flux. I do have a bottle of it here somewhere. It's MG Chemicals, number 835. Anyways, that's the number of the stuff that I use. Now, I have the 835-1L, which means 1 liter. So I bought the big, 1 liter bottle of it. But I think they have 500 milliliters and smaller bottles of this stuff as well. That 835 is by far the best flux I've ever used. And I put it in this little ink bottle that you see here. And I use this to dispense onto circuit boards. So you take the little cap off, and then you dispense it. And when you're done, you put the cap back on, and you can set this thing off to the side. Now, I've talked about safety with these flux bottles before, and I'll mention it again. If you're going to use any type of a flux bottle that has a needle on top of this thing, you need to be extremely careful. Because if you set this thing down like this and you don't put the rubber cap on and you bend over, there's a good chance you could poke yourself with this. You definitely don't want to do that. So a lot of people will break the needle off right down here. It does make things a whole lot more safe, but it also creates a whole lot of other problems at the same time. You get flooding of this, and you get big gobs of flux ending up on here, and then you'll find up you'll get a really big buildup down here, and it's a lot harder to I guess you could say gauge how much flux you want to add to a board without the needle on the top of the ink bottle. So if you ever use an ink bottle like this, you're definitely doing so at your own risk. Be very, very careful, and it even says here, avoid contact with eyes. That what I guess would have been the ink. But you definitely don't want to get this thing anywhere near your head. Whenever you're done with something like this, you always want to put the rubber cap back on the top, and you want to set this far away from you so that if you were to ever bend over, that you could not come in contact with it and ever bump your head. You definitely never want to poke your eye with something like this. That would be the end. So you got to be very, very careful. So again, if you're more comfortable with breaking the needle off, these work very good. It has a very small little piece of this is a stainless little pipe, a little small piece of stainless in there, and that'll work. You'll just find that this will flood a little bit on the end after a while. And for those of you that have done that, I'm sure you know what I'm talking about. So very, very handy. The flux is very important for any surface mount work. You can't rely on the flux that's in the solder, especially down when you're dealing with a 402 and even a 603, things like that. You need to put flux on the board, and you need to clean this off. Now, when I'm cleaning the flux off, I use lacquer thinner. That's what I use myself. Put on gloves, do it in a well-ventilated area. I'll get a toothbrush that doesn't get attacked by the lacquer thinner. I'll pour a little bit of lacquer thinner in the cap, and I'll dump it on the circuit board, and I'll scrub the circuit board with a toothbrush to clean it off. Now, things where you need to be careful with lacquer thinner are the like capacitor shells, like the writing on the capacitor shrink tubing that they put on the actual capacitor itself. If I had one here, I would show you, but I don't on the bench. So any capacitors, they've got the writing on it. They'll say Nichicon, Rubicon, whatever, and all that writing will come off if you touch it with lacquer thinner. Now, I used acetone, works okay. Alcohol is a real pain to use, but it works, and it leaves kind of a white residue on the board. And that's even at the high, 99% stuff. Lacquer thinner by far is the quickest, easiest, takes the flux off, and will leave you probably with the cleanest product in the end. All right, let's do some 0402 soldering. So I've changed the tip in my iron to my favorite soldering iron tip. That's usually the one that sits at the bench right off to the side of me here. So one of the very first things that I want to do is apply just a little bit of flux to the boarding, and I also want to clean my tip so that there's just a skiff of solder. I'm going to use the solder that's left on the tip after I clean it in this to tack that component down. So what I'm going to do is zoom way in. It's going to be shaky here for a moment. Zoom way in. Now I'm going to add just a little bit of flux to the board here, and if you add too much, you can always dab it off with a Q-tip or something like that, okay? So what I'll do is I'll just grab the component. Now, as you can see, I'm working this way because it's easier to do this. I'm going to grab the component, put it in that puddle, move the puddle around a little bit, smear it around with that component. So now what I want to do is I want to make sure that that component is in the center of those pads, okay? So you can see the center of the pads. You can see if I do this, I can get a pretty good idea of how centered my component is. Now, I find myself compensating for older tweezers all the time. The tweezers won't sit square with the component just because the tweezers are used. Sometimes they're off to the side just a little bit. So that's about center of the pad. So now what I'm going to do is clean the tip off. The tip is cleaned with that brass, almost looks like a kitchen scouring sponge, but it's cleaned with that they're all like brass shavings. I don't even know what to call that thing. Tip cleaner, that's what I'll call it. And then what I want to do is just tack this one side like so. Once that side is tacked, you're good to work on the other side. So what you can do is add just a little bit of your favorite solder to the soldering iron tip. So you can add just a little bit more, just a touch. Okay, so I'll try and show this in the shot. Just a touch. Okay, you can see that it pretty much pulls the solder up just a little bit. So then what I want to do is just come in on this side, touch it there, like so, go back onto this side, touch it there, go back onto this side, touch it like so. See it actually move the component just a little bit, and just like that. And you can see, try and get this as close as I can. I think that's out of the focal range of this lens. It's zoomed in so far. Let's see here. That's about it. Right about there. I don't know if you can see that, but it's completely soldered. Hard to see with this lens. What I'll do is I'll put on another lens here in a little bit, and I'll show you what that's like. Now, the thing is with these components is it's always a good idea just to tack one side first. And I like to work this way. So if we were to zoom out on the bench here, you can see that I'm working like this, right? Now, a lot of the times I'll just keep everything fixed like this. And then if I want to work on the other side, I'll come over here and I'll just tack the other side. And sometimes I'll even put down pressure on the component if I think it's going to come loose, like it did right there. Now, I have to admit, I'm looking at a monitor, so I'm soldering this in a monitor right now through the actual lens of the camera, so I don't have the same look on things as I did. It turned out absolutely fine just the way it is. Now, another question I get with components is, so I've printed off, like usually when I create a project and release a project here on Patreon, I include a PDF with the board layout. Okay, so the printed circuit board is sized and everything, and people say, well, how do I know if the size is correct. Well, on that piece of paper, what you can do is you can print off a dummy piece, okay? On that piece of paper, take an IC and just drop an IC on that piece of paper. If it's scaled correctly, the pads will line up perfectly with an IC. I'll just try to grab an IC of the same pitch here. Let's see if I've got one that's somewhat loose. I don't know if the pin count is the same, but you'll get the idea. At any rate, so basically what you want to do, get yourself an IC and take that IC and then just drop it. I'll zoom on in again. What you want to do is just drop that onto the actual paper, and the pads should line up just like that. If the scaling is correct on the piece of paper that you've printed off to do your toner transfer. So it should just be exactly the same as what you see. And then of course that's mirrored and it transfers onto this. You can actually see this is really thin copper. You can see the circuit board's got ribs in it. The actual material has ribs, and you can actually see the ribs in the copper itself. Just the way it turns out. Puts the pattern right into the copper. So that's that. That's how you tell the actual size or the scaling, if your scaling is correct, if you're unsure about your printer. Just take an IC from the project, drop it on the paper, and if all the pads line up just like that, you know the scaling's correct at that point. If it's off, these are going to be off at either end. They'll be either too wide or too narrow. And for drilling vias, of course, if you want to drill vias, I try to keep vias out of projects, and I try and keep everything single-sided, but sometimes I just can't. And of course, you need a Dremel and a Dremel press to do this with some very small carbide bits. And then you just drill through these. And I've showed this in many of my other videos. I still left the toner on this side. So, yeah, I've shown this in many other videos, how to get the alignment correct with the package or the sandwich type thing. One thing to keep in mind, if you're going to ever make extra circuit boards and you're going to have them off to the side, leave the toner transfer on them until you're ready to use the circuit board. And at that point, take your lacquer thinner and wipe the toner transfer off. I did that with this side, and as you can see, the copper's all nice and fresh on this side. If you wipe that toner off, and then this sits for 6 months with just bare copper, the copper will end up tarnishing. So this protects the copper. So all boards that I build and I don't use right away, I just leave all of this on here. This one here has been used as a sample and kicked about a little bit, so as you can see, it's kind of scraping off. But I just took the toner off this side just before I soldered this one little component on here. So that's how easy it is, just like that. ICs, you hold the exact same way. So put the IC down here and just hold it like so. Hold it onto the pads, so get everything nice and centered. Okay. Again, I'm doing this through a monitor and a camera here. So you get everything centered till everything is about middle of the pad like so. And then what you do is you tack just one pin. And then it'll hold it in place. And then if you've got it a little bit crooked, say it's not exactly where it needs to be, you can bend it around just a little bit until it's, straight on the pads. You can see it's little legs are catching on the pad. So if it's a little bit crooked, you can always bend it and get everything just perfectly straight. That's what I do if anything is crooked. And then at that point, you solder the second pin, the adjacent corner, and then it's tacked into place and it's held completely even. And then you go around and then you solder all the other pins. And then in the end, you go and resolder those pins. And again, flux really is the key. Like you can see, like there is no flux on this tip right now, right? And this is pretty fresh copper. This might be a bad example, but I'll just touch this on here. This is pretty, you can see, right? You can see that solder ball, it doesn't want to take, right? See that? It's not even taking to the copper. Now watch what happens when I add flux. Okay, so I'll add just a touch of flux to this here, like so. Okay, and you can see it's hot. Now watch what happens when I look at that, how it just flows right out. See that? So flux is the absolute key to making anything solder correctly. If you're to use just standard, like this is the, this stuff here is the lead-free stuff. Okay, so clean the tip off. And there is just a little bit of flux in this, or it wouldn't take it all. You can see it's not working out too bad with just this, feeding this in here, right? You can see it didn't get that corner there quite as well as I would have liked it. So what I'll do here, it's still hot, I'll probably boil on it. So now with that there, look at that, how well that flows out. Now this is imperative for drag soldering. See, look at the difference, right? Lead-free solder to leaded solder. You know, you get this dull looking kind of thing happening there. So I'll completely solder this one. I'll add a bit more flux to this one here. Give you an example of the difference, right? Nice. Look at that, you know, nice chrome ball. Almost chrome ball. That one didn't solder so nice. You know why? Because I've got lead-free solder on the tip of my iron. That's why it's doing that. So what I'll do is I'll just wipe this off. And I'll give this some leaded solder. All right, so I just tinned this with leaded solder. Now there won't be any contamination here. And let's try here. So there we go. And as you can see, like, look at the difference in that, right? That's just with just the slightest bit of contamination with the lead-free on there. So you can see the difference there. Again, I'll put on that other lens here in just a little bit so we can get a better view or better idea of what's going on, right? So if I get, what I'll do is I'll clean this all off. I'll clean the flux off here. I'll show you how that works as well with a Q-tip here in just a moment. But yeah, just, you know, what a difference in the look of the solder right there. So that's pretty much it. There's no real rocket science to doing this. A lot of people, what they want to do is they want to use solder paste on the board itself and then, you know, heat the whole board up and solder it. For stuff like this, it's not even, I wouldn't even bother, put it that way. I wouldn't go buying solder paste and trying to heat the board up and doing that. A lot of times, if you don't get the heating correctly, you'll damage new components by trying to do the, you know, by heating the component and having it flow into place. By using a soldering iron, you know, you're just applying heat to one leg at a time, nice and carefully, and you're going along, and you know that all the components are going to be absolutely fine when you're done. Whereas if you're baking something with a hot air tool, trying to heat the whole area up, you're heating the IC up at the same time, you know, just to, you know, flow the solder out. There's a good chance that, you know, unless things are, you know, they don't need to be perfect, but, you know, a little less than perfect, you might damage some things, damage some components. All I did was clean this area off with a little bit of lacquer thinner, and you can really see the difference in the solder. So this is leaded solder contaminated with lead-free solder. This is full lead-free solder, and then this is 60/40, nice clean 60/40 right there. And I could have probably, you know, cleaned the tip one more time and then gone back and redid that again. You can really see the difference. So you get that nice kind of a chrome look out of the center one there with the 60/40, whereas these are really dull. Now, of course, if you're not concerned what your soldering looks like, you know, like at that point, who would really care, right? But I like my work to look really nice when it's done. And you can see the solder on the little 0402 part right down there. So hard to get a real good idea of the actual profile because it's a really small component. And, you know, looking at this at any angle, at any different angle, light shines off the solder. And of course it makes it look weird, but that is a really good solder joint right there on that little 0402 component. A great magnifier that I picked up a little while back is this one right here. And as you can see, there's quite a difference just by using this here. And of course, you know, you lift it up a little bit further, the magnification gets a bit better. So this is just from a local place. This here, I'll try and zoom on in just a little bit. So you can see here, it's that's the company and that's who makes it. So it has a nice row of LEDs here, nice and bright. And as you can see, makes quite a difference. There's the board without, and there's the board with. Now, the reason that I chose this oblong kind of lens, almost a rectangular type of lens, is there's a lot less distortion in this particular type than the perfectly round style I find myself. So I looked through a lot of these, and I found this one here with this kind of a rectangular type of lens had the least amount of distortion. So it's comfortable to look through for a long period of time. Let's put it that way. I find that the round lenses, the perfectly round ones, they and kind of get a little bit bothersome after a while. So this here works very well. And these are a real cost-effective solution if you don't want to go out and purchase a microscope. So very, very handy. Just back this off here. This is a floor standing unit, by the way. So it's got this kind of a neck on it. You can see this. You can move it over like so. It's nice and sturdy. And has a stand that sits on the floor. So right now, this is actually being held by the floor. There's a weighted stand, I guess you could say. And you can lift it up or down, and it has this flexible gooseneck on it. So definitely a nice handy little magnifier to have around. Works well too if you want to do drilling with a Dremel. So you can back this away from the Dremel bit, and this will really, as I say, magnify the Dremel bit where you're going to be working on the circuit board, things like that. Makes it a lot easier to target the vias and things. Coming up very soon, I'm going to have a tutorial on desoldering surface mount components from either your own board or commercial style circuit boards. I found a very cheap hot air tool that works extremely well. And again, it's a hot air tool with a soldering iron, and the soldering iron happens to use that 936 tip, like I was explaining earlier. So many of these offshore companies are using that particular design. So that worked out very well. So I can interchange my Hakko or Hakko tips into that unit and use it as well. So I'll talk all about the desoldering video here very soon, and I'll show you how easy it is. Really, really easy to desolder components from surface mount boards. In fact, in some cases, it's easier than desoldering through-hole components. I'll show you all those techniques in the upcoming video here. So I hope you enjoyed. If you did enjoy this video, you can let me know by tapping the heart symbol below, and I'll talk to all of you very soon. Bye for now.